Hello guys. Now we're gonna solve, or in this video we're gonna solve a problem or finding the derivative of trigonometric functions, derivative of logarithmic functions, exponential functions, and also gonna solve problems involving maxima and minima. So let's start. Now we're gonna find the derivative of a trig function problem, or the trigonometric functions. Okay, and we have this as an equation, and we must find the derivative of these terms. And at first, it quite so difficult, and it has a lot of work because they have a lot of functions and terms on this equation. But in the rule of derivation or derivatives, we must follow the three steps. The three steps. And what is that? First is we must simplify the equation if possible. Second is to find the derivative. And third is to simplify again. That is the rule of derivatives. Now we're gonna do this and apply this rule on this in our problem. So why? What is the common terms or common factor we can pull out so that the equation will be minimized or will be in the simplest form? And notice that they all have 3x. They are all divisible by 3x. So we're gonna pull out the 3x. 3x. And leaving us with 2x plus secant squared of 2x minus cotangent squared of 2x minus tan squared of 2x plus 18x divided by 3x is 6 sine x cosine x. And now we have a simplified form, but we can simplify it further because notice on these four terms they all have squares on it, and that reminds us of a trig identity, specifically the Pythagorean identities. In the Pythagorean identities, 1 is equals to cosecant squared x minus cotangent squared x, and also 1 is equals to secant squared x minus tan squared x. So 1, we can replace 1 on this cosecant squared of minus cotangent squared. That also goes the same on this, right? So okay, we can replace that. And also, we can replace also 1 on secant squared of 2x, these terms, and minus tan squared of 2x, right? So we can do that. We must do that. So we have y is equals to 3x times 1 plus 1 equals 2, right? So 2 plus this term is a double angle identity. In double angle identity, for example, 2 sine x cosine x, it is equals to sine of 2x. And if we can apply that on 6 sine x cosine x, that will be equal to 3 sine of 2x, right? So 3 sine 2x, we can substitute 3 sine 2x on 6 sine x cosine x. So we must do that. We do that. 3 sine of 2x. Now, we can distribute 3x on these two terms. So y is equals to 6. 3x times 2 is 6x. 3x times 3 sine 2x is equals to 9x sine of 2x. Now, we can find the derivative. The derivative of 6 is simply 6. Plus, this is a product of two terms. And we can apply product rule on it. In a product rule, the derivative of the two functions that is being multiplied is equals to derivative of the first function times copy the second plus derivative of the second function times copy the first. That is the product rule, and we must apply that on our problem. So the derivative of 9x is 9. We will copy the second term is sine, which will be sine 2x, plus the derivative of sine 2x is the derivative of sine in a function of u. If we must find derivative, it is equals to u prime, which is the inside derivative of the trig function, times cosine of copy that function. That is what we must follow. So we have derivative of 2x is 2 cosine of 2x times copy the second 9x. We can simplify this further. We can pull out 3 because all of these terms is divisible by 3. So 3 is being pulled out. 6 divided by 3 is 2 plus 9 divided by 3 is 3 sine of 2x plus 2 9x divided by 3 is equals to 3x times 2 is 6x cosine of 2x. And now we have this as our answer on this Now we're
problem.
gonna move to the derivative of logarithm. We are gonna solve two kinds of logarithmic derivation. First is the derivative of our logarithmic functions, and second is the logarithmic differentiations. So we're gonna first derive the logarithmic function with this of example. So in this example, as we know on the rule of a logarithm, ln of a over v is also equals to ln of a minus ln of b. So we're gonna apply this rule on our problem. So we're gonna do that. So y is equals to ln square root of x is equals to the raised to the power of 1/2 times minus ln of x squared plus 4. This 1/2, as we know also in the rule of logarithm, is when you have an exponent in a logarithmic equation or a term, you can move the term on the coefficient of that logarithm. So we can also write this as 1/2 ln of a. So we're gonna do that. We're gonna move this 1/2 to the front. So we have 1/2 ln of x minus ln of x squared plus 4. Now we're gonna find the derivative. So y prime is equals to 1/2 ln of x is equals to the derivative of logarithm with ln with the base of e is equals to, if we have a function of u, that is, if we're gonna find the derivative of that, it will be 1 over u, 1 over that function times the derivative of that function. Okay, so we're gonna apply that on our example. Ln of x, 1 over copy the function that is x, and the derivative x is 1, simply 1, minus also this 1 over x squared plus 4. The derivative of this is 2x. So we're gonna simplify that. So y prime is equals to 1/2 1 over 2x minus 2x over x squared plus 4. So now we have this as our answer. Now we're gonna use the differential logarithmic differentiation on solving this. We find the derivative of this problem or this equation by using differential logarithmic differentiation. In the logarithmic differentiation, we will only use that if we have a base function and our exponent is also a function. We can use that logarithmic differentiation. And we can see this in this example, they are all function. Their base is function and their exponents are also functions. So we're gonna do that. So we're gonna distribute or multiply ln to both of sides. So we have y ln. If we multiply ln to this term, the y is gonna put on the coefficient, then ln of x equals also on this we're gonna do the same. Now we are now gonna find the derivative like that. So this is a product rule. This is a product of two functions. So we're gonna use product rule. So product rule we are gonna use if we're gonna find the derivative of the product of two functions. First is we must find the derivative of the first, then copy the second, derivative of the second, copy the first. Okay, that we're gonna do. Now you're gonna do that. So the derivative of y is y prime, and copy the ln x plus the derivative of ln x is 1 over x. Then copy the first term or first function equals the derivative of x is 1. Copy the second function plus the derivative of ln y is 1 over y. The derivative of y is y prime times we're gonna copy the x. We're gonna only copy the x. We're gonna simplify this term. So y prime ln x plus y over x is equals to ln y plus y prime x over y. We're gonna put all terms with y prime on this side of equation, and those who have not, we're gonna put on the right side. Okay, so we're gonna do this. We're gonna transpose to this side, and this we're gonna transpose to this side. So if we're gonna put y prime x over y to the left side, it will be gonna negative. It will be negated. So y prime ln x minus y prime x over y equals, also that will do the same with this y over x, ln of y plus y over x, right? Oh, minus y over x. Yeah. And we're gonna factor out the y prime, so it will be leaving ln x minus y x over y equals ln of y minus y over x, right? Yeah, right, yeah. Now, can I erase this top portion? We're gonna divide both sides by ln of x minus x of y, so that this will cancel out. And ln of x minus x over y, yeah, that. So leaving us with y prime is equals to ln of y minus y over x all over ln of x minus x over y, right? Yeah. Now, this is our find the rectangle maximum perimeter inscribed in a given circle. So this says that if we have a circle with unknown sides, we can find what is the maximum perimeter of this of this rectangle inscribed in a circle. So we're gonna find the perimeter, right? So we can find that by only using the perimeter. We will use this and put that it will be the diameter, right? This is the diameter of a rectangle or a rectangle, yes. And we say we can put this as x as is one side and y as its length, right? Yeah. So in finding the diameter, this is a triangle, right triangle. So d squared is equals to x squared plus y squared in a Pythagoras theorem. So we're gonna find the derivative, first derivative of this. So if we do that, since this is given or this is a constant, derivative of a constant will always be 0. Derivative x squared is 2x. The derivative of y squared is 2y prime, right? We're gonna transpose this to the other side. We have 2y prime is equals to negative 2x. Gonna divide by 2y. It will be y prime. 2 divided by 2 is negative. Negative 2 divided by 2 is negative 1. Negative x over y. So we have this kind of problem. So we're gonna find the maximum perimeter. So perimeter is equals to 2x plus 2y. Perimeter is at its maximum. So this is a given. So this will be assume that it is given. So to find this, the derivative of this is the derivative of a given or the constant is 0. It always just like on that side. The derivative of 2x is 2 plus the derivative of 2y is 2y prime, right? Yes. So we substitute y prime, which is negative x over y, to this. So 0 is 2 plus 2 negative x over y. Right? Yes, right. Now, we'll multiply all terms by y so that the denominator will be cancelled. So y divided by times 0 is 0. Y times 2 is 2y plus y times 0 together by y is 2 negative 2x. We transpose this to the other side. We'll get 2y is equals to 2x. We divide by all terms by 2 and we have an answer of x is equals to y. So the sides of a rectangle inscribed on a given circle, which gives it a maximum perimeter, is when the sides are equal or when they are on squares, right? When the sides are equal, that will give you the maximum perimeter, right?